Hello everyone and welcome to today's chemistry class. In today's class, we'll be looking at WAEC chemistry past questions between the year 2008 to 2020 on the topic periodic table. Year 2008, question 37, it says, which of the following statements is not true of halogens? A. They exist in different physical states. B. They exist as diatomic molecules. C. Their ionic radii decreases down the group. And D. Their melting and boiling point increases down the group. Option C is not true and is therefore the correct answer because the ionic radii of halogens actually increases down the group. This is because as you move down the group, the number of energy levels increases, which results in a larger ionic radius. Another question from the year 2012, question 40. It says, the atomic radii of metals are usually A. Greater than their ionic radii, B. Equal to their ionic radii, C. Less than their ionic radii, and D. Less than those of non-metals in the same period. The atomic radii of metals are usually less than their ionic radii. This might seem a bit confusing at first, but it makes sense when you understand what happens during ion formation. Metals, by their chemical nature, tends to lose electrons and form positive ions. When a metal atom loses an electron, it becomes a cation and its size decreases. This decrease in size is because the electron cloud shrinks due to the reduced electron repulsion in the outer shell. As a result, the atomic radii is typically larger than the ionic radius. On the other hand, nonmetals typically gain electrons to form negative ions. When an atom gains extra electron, the increase in the electron-electron repulsion causes the electron cloud to expand, making the ionic radius larger than the atomic radius. So, the atomic radii of metals are usually less than their ionic radii because metals form cations by losing electrons, which cause a decrease in their size. Another year, question 42. The D block elements are paramagnetic because they A. Contained paired electrons which are repelled by magnetic field. B. Contained unpaired electron in the partially filled 3d orbital. C. Contained paired electrons which are repelled by magnetic field force. And D. Have delocalized valence electrons. Paramagnetism is a form of magnetism that occurs only in the presence of externally applied magnetic field. It is due to the presence of unpaired electron in the material, and the magnetic moments of this unpaired electron align with the magnetic field, resulting in a net magnetic moment and causing an attractive force towards the magnetic field. In the context of the D block elements, these elements are often paramagnetic because they have unpaired electron in their D block orbital. The D block elements are the transition metals and they are known for their variable oxidation state and the ability to form complex ions. The element configuration of these elements often results in partially filled D orbital. So the correct answer is option B, which is contained unpaired electron in the partially filled 3d orbital. Another question, year 2013, question 31. In the periodic table, alkaline earth metals can be found in A. Group 1, B. Group 2, C. Group 6, and D. Group 7. So the correct answer, obviously, to this question is B, which is Group 2. Another one, year 2015, question 40. To which group and period, respectively, does an element with 15 electrons belong? A. 3 and 3, B. 3 and 5, C. 5 and 3, and D. 5 and 5. The question is asking you to identify the group and period of an element with 15 electrons. We can do this by understanding how the structure of the periodic table relates to an element's electron configuration. In the periodic table, the period number corresponds to the energy level of the element's valence, that is the outermost electron. The group number, which is for groups 1 to 18, corresponds to number of valence electron. The first 20 elements follow this pattern directly, but after that, transition metals and inner transition metals complicate the pattern. The element with 15 electrons is phosphorus. Here is how we determine this. The phosphorus electron configuration is 1s2, 2s2, 2p6, 3s2, and 3p3. The first number in each term shows the energy level, and the superscript shows the number of electrons at the energy level. The highest energy level is 3, which means phosphorus is in group 3, is in period 3. The last term, 3p3, shows that phosphorus has 5 valence electrons, 2 from the 3s2 term and 3 from the 3p3 term. This places phosphorus in group 15 or 5a in the older notation, because the group number corresponds to the number of valence electrons for non-transition metal. Therefore, the correct answer is option C. That is, phosphorus belongs to group 5 and period 3.